All right, so today is November 15th, ITS 128, and we're in the last day of covering chapter 7, which is arrays. So I got a little bit of catching up to do, and I think we do that pretty well with assignment 11. So I think what I'd like to do today is sort of focus on what you need to know for assignment 11 and sort of wrap up maybe some things I missed on 10. But so let me switch over to screen. And so here we are, right, this day. Today's the 15th. And with assignment 11, I did include a little bit of stuff out of, well, let's see, there's a little bit of collections in here. There's two-dimensional arrays, which is covered in the last half of chapter 11. In fact, I should probably bring that up so you can see it. I'm going to take this, and if I scroll all the way down to chapter 7, let me make it bigger. This is an algorithm to find the smallest number in an array. But it would be good to just take a look at these algorithms. They're very simple, and it's code for doing typical things that you might do with an array. One is maybe totaling up all the values of an array. Let's see if this works today. This one calculates the average of an array, and basically it iterates through the array, totaling up the scores. Each score, it adds it up, and then divides by the length of the array, which is divided by the number, and that gives you the average, of course. And this one finds the highest, so basically each time it loops through the array, it sees if the number it has stored as being the highest is still the highest. So if it encounters a number that's larger than what it has recorded so far as the highest, then it sets it to the a new value for highest, and same with lowest and so on. And then we get into, here's a selection sort. We actually do have a sort in our assignment 11. And so there's several different kinds of sorting methods. And if this were, we'll probably get more into it in 148. But part of computer science is to analyze what's called the computational complexity of algorithms. And analyzing sort algorithms, the various standard sort algorithms, is a good way to introduce ourselves to that. And so the algorithm doesn't make much difference if you're only sorting 10 or 100 or 1,000 or perhaps 1,000,000, but or 10,000. But when the numbers get pretty high, like million, 10 million, and the sort is in the critical path, then it can really make a difference. So anyway, this is a selection sort, and we're going to do an insertion sort, and you'll see, you'll understand what that means. But in most sorts, there is a inner loop and an outer loop. And so for every for every, so if the outer loop has to touch each element of the array, and the inner loop has to touch each element of the array, then we've got, you know, if there's 10 elements in the array, then we have 10 touches times 10 touches, which is 100 touches, and so you can see it's sort of an exponential growth. And here's a binary search algorithm, which is a that takes advantage of the fact that if an array is sorted already, then to see if a particular element is in the array or not takes the log to the base 2 amount of steps as there are elements in an array, which means if there are you know, if there's 100 elements in the array, it takes about 7 steps to find it, to see if it's in there. If there's 1,000, it takes about 10. If there's 1,000,000, it takes about 20 or so. And the reason is because you can with each check, with each comparison, you eliminate half of the set that you're looking for, because you basically split the difference each time, and so that's another algorithm that is way faster when you get to large numbers. It's way faster than a simple search, which starts at the beginning and goes all the way through until it finds it or not. In that kind of search, you don't assume that the array is sorted. So anyway, next is two-dimensional arrays, and they can be visualized more or less like this, where you have rows and columns. And so, for example, and this sort of looks more like a spreadsheet, but so for this particular example, we have a row for each student, and we have a column which represents, say, for example, scores. So let's say we have 5 scores and we have a bunch of students here. We might have an array that looks like this. Now, and the way you reference elements in the array is you have the name for the array, and then you have a row and a column. The first digit here, or subscript, is the row, and the second one is the column. And this is how you declare it. You put a comma in between the 2 brackets. Here you're declaring a 2-dimensional array of scores, and it's an integer array, and here we're specifying the size. So there's a rows and a column. And so this is how you refer to them. All right, so we're going to use that in our assignment. We're going to store our friends' names, first name and last name. So we're going to have a 2-dimensional array. It's going to have 2 columns. The first column is the first name. The second column is the last name. And each row is a friend. Excuse me. All right. So here's some example algorithms that we might use for processing 2-dimensional arrays. There's a concept of jagged arrays, where the number of elements in each row can be different. And then we have lists, and lists are like arrays. You have the same kind of operations on the list, except for they're actually stored in memory differently. And because of the way they're stored in memory, you don't need to specify a maximum size when you declare them, because the list grows as the amount of memory that the list uses grows as the list grows. And but you're still able to index. There's still an index, and there's still there's various other methods that go along with lists that are more convenient and easy to do with lists. They're more efficient than they are with arrays. For example, if you want to insert something in the middle of a list, it's a constant operation because it's the list elements are not really stored in order in memory. They're sort of linked to one another. And so, whereas if you need to insert an element in the middle of an array, there's a lot of shifting that has to go on. This is how you declare it. You declare a list type, and so this is a list. It's a string list. It's a list of strings. It's called name list, and I still haven't gotten the hang of this. It is a list of strings. Name list is a new list of strings, and so you can initialize a list similarly to arrays. All the various ways of doing it. The way you add items to a list is you do it this way. Now, this should look very familiar to you. This is exactly how you add items to the list box. In fact, the list box dot items is a list. It's a list of items, and so that's why when you add a name to a list box, you use the name of the list box dot items, and items is a list dot add, and then what you're adding is in quotes, and so because it's a string, it's actually more than a list of strings, because there's other things that go along with it. There's actually no, a list box actually is just anyway. The operations are the same. The methods that go along with it are the same. So lists are not really new to us. There's the count property. There's not a count property with an array. There's just the max size, and array elements are either filled with something or not. And you can access items out of the list the same way as you would out of the list box, but also with an array. Also, you can refer to them by index. Removing items from a list it's easy. It's kind of like you have this string where each element in the string, it's like a string of pearls, sort of, where each pearl is independently connected to the next pearl, and then the next pearl is independently connected to the next pearl. So it's not like you have a single string going through all of them. But if you want to remove a pearl, you just disconnect the front and the back of a pearl, and take it out, and then you connect up the one that the pearl was in front of. You connect that one up with the one that the pearl was behind, and so it's just again, it doesn't matter how many pearls are in the list. It's still like a fixed finite amount of time. Whereas with an array, if you want to pop something out of an array, you take it out, and then you have to shift everything below it, up one. All right, and inserting is the same. You normally insert at the bottom of the back of the list, but you can insert in the middle if you want to, if you need to. And let's see. If we quickly look at Chapter 8. Chapter 8, we talk about strings. Oops, wrong. I didn't mean to cross that out. Is there any erase? I think I can erase. Oh, good. So we're going to do a little bit with strings, and strings are actually an array of characters. That's sort of a character is just one character, and you can actually refer to the characters of a string that way. Let's see. So, and the reason you would do it is because you may want to do certain tests. For example, you know, you've had to change your password before, and somehow the system knows if you've got a capital letter and a lowercase letter and a digit and all that. You know, it's doing something like this. It takes your string and it converts it into characters. Here's an example. You have a string, and here you're defining a character type called a char type letter, and here you are looking at all of the letters in a name, and then here now you can't display out a character. You have to convert it to a string. It sounds kind of dumb, doesn't it? But you do. So this converts it back into a string, and this is going to display one letter at a time of Jacob, J-A-C-O-B, I guess. But then here you can do these tests, and this would return a true or a false. If it's a digit, if it's a letter, so on. So there's different functions like that take characters as arguments. And you can capitalize. In fact, we use that in the in assignment 11. Ooh, I forgot to add that. All right. So then there's substring methods also. This is, you know, this is a string variable now, and there's methods that go along with that. Contains, which will return true or false if it contains a substring, contains a character. If it starts with a substring, if it ends with it, here's a index of. This is index of string of. This is returns the position of a substring if it exists in the string. So you know, if you were to look for the word, if the substring were itch, let's see if this works. Let's say you're looking in no, it doesn't. It's not. Oh, R-I-C-H, and you were searching for the word itch. Then that would be, this is the 0th position. This is the 1st position, the 2nd position, the 3rd position. This is not working very well. Sorry. But anyway, it would return a 1, because that's the position of the substring that you're looking for in the complete string. Anyway, and this is beyond a particular point. We can use index of a list. The index of method, it's not shown in this textbook, but if you search list, if you search for list methods in C#, you'll find that there's an index of, and you can use that on a list box. So we can see if John Jones is a name in our list box just by asking for listbox.index of quote John Jones, and if it's in there, it'll return the index of it. If it's not in there, it'll return -1. So that's a quick and dirty way of doing that function, that button that you need to do in chapter 10. Let's see. Let me look at the, wait, no, you don't want to see me. I think you're seeing me, aren't you? Sorry, I didn't mean to. If you go to this in list button. Anyway, I'll show you that. Let's see, where is the, okay, anyway. So those are some string methods, and we know about methods in strings and methods and strings and so on. So that's and we are actually going to use the two upper and the two lower also. And then I think, is that as far as I think that might be as far as I take us. Yes. Oh, split. Where's split? Let's see. Sorry about the. Tokenizing strings. Here we go. There's a function. There's a split function, and what that does is you it's like this. All right, it's like this. Okay, so you have a string, and what it'll do is it'll split it up and create a string array. It'll create a string array. In this case, it creates a string array called tokens, and it'll split this bigger string where whatever you put here, whatever you put there is the delimiter. Okay. So in this case, in this example, the delimiter is a semicolon. So if the string is, well, if the string is this, the array is going to have, the array tokens is going to have 4 elements, and element 0 is going to be the word 1. The token 1 is going to be the word 2, and so on. And the semicolons will not be around anymore. Okay, the semicolons are the separator, so you won't see the semicolons anymore. Now, it turns out that if you don't specify anything, if you just leave this nothing, if you actually do put nothing in there, then it assumes, or then it splits on white space. So that means, so this is what we use to split our name into first name and last name. We simply, the new name is this string, str, and we say split, nothing. So then it's going to split the first name from the last name because you're going to put a space in between the middle. And the first one is going to be the first name, and the second one will be the last name. So I want to show you that. And you can specify the delimiter as a set. And so this will split on either an ampersand or a period. So for example, if you're looking at a email address and you want to split it up into 3, Joe, Gittes, Books, and Com, you can do it that way. All right, so let's, so I'd like to go back to our assignment here, and let me go to my Dropbox, and it's this one, and I'm gonna pop out I don't know, one of these assignments, starting assignment. Let me do was this yesterday? Yeah. We'll do this one. No, I'm not gonna. I'll do this one. Open. And I guess I can put this on the desktop. Close that. Close that. So let me open this up. Open this up. Visual Studio. And while that's opening up, let's take one more look at the assignment. And so, what I'd like you to do for assignment 11 is change the array of names to a 2-dimensional array with 2 columns. First column holds the first name, second column holds the last name. And when the user enters a new friend's name, the first name it'll be first name, last name with a space. Use the split string method to split it into first and last names. And I'll go over all this today. Then I want you to when you store the names, I want you to store them in alphabetical order by last name in the array. And I tell you to shift. Basically, you're really shifting. You're shifting names down until the position opens up where you would insert the new name, and I'll show you that. And then fix names so the first letter is capitalized and the remaining letters lowercase. There's one more thing I forgot to add. Anyway, so let me go through that. I have to sign in first. All right. So let's start by just running this and seeing what it looks like. All right, it looks like this. Let me didn't load anything. Let's load the file, see what we got here. Let me go down into here, into here, into here, into here, and let me click on, let's say this one, friends 4. And so it's these 3 people, and so I can add somebody and save the file, and it rewrites the file. All right, that's great. Oh, I remember what it was. Okay, so so let's let me open up the thing here. First of all, let me throw in that check name function. Now some of you have already done it, and if you've already done it the way I told you to, it's a better way than what I'm going to show you now. So I'm more or less just showing this to you. But if you're somebody who's just baffled at how to do it because I didn't show you specifically how to do it, you know, to check if somebody's in there or not, you can do it this way. But it's not the best way to do it. So, but let me so I'm gonna just hang on. Can I have to wait until it lets me start doing things. Okay, so I want to make a copy of this button. Copy, paste, copy, paste, and put it over. Let's see, now I want to put this one over here because this one's the one that works. I'm going to put this one up here, and this is going to be my check name. Let me make this bigger. So this is the one that doesn't do anything. See, it's called button 1. The text is going to say check name to see if that name is in my friends, and I'm going to name it btn check name. And so let me double click on it, and so this is it. And so I'm going to look at the what did I name this thing? Is this thing named anything decently? Name text box. That's a bad name. I'll never remember that. TXT new name. Okay, I'm basically renaming the text box because I want to refer to it now. So let me go back here. Here it is. So I'm going to say string new name equals TXT new name dot text. There's the new name. And what you can do is do if lst friends dot items dot index of parentheses new name, if that is greater than or equal to 0, then it's in there. Message box show your friend name is in there, is in here, whatever. Okay, otherwise, message box show name not present. All right, so I'm going to say your friend quote plus new name plus quote. All right, your friend Joe is in here. Name plus new name plus quote is not present, whatever. All right, so let's test it. Start. And I'll load up the file with something. So I can test is Fred Johnson, check name. Your friend Fred Johnson is in here. How about it? The problem with this is it considers case, and you might not want to consider case. The other one, Joe, Fred, so I can do Fred. I'll do lowercase Fred Johnson, and we see the name Fred Johnson is not present, see. So if you were to do it the way I was telling you before, which is somehow use this, well, use that. You use this except for you're not loading it into an array. And you aren't, you know, you don't have to, you take these change happen, you take the save button, save file enabled, you know, take that out. You're only looking for a duplicate, and this will say if there's a duplicate or not, and if there is a duplicate, then you say, you know, it's the name's already in there. So that's actually the better way to do it because it considers case, it ignores case. All right, so that's that. Now, so to get started with this new array thing, let me see where we are. Change the array to a two-dimensional array. So what I'm going to do is I'm going to, this is a, you know, part of what I should be teaching you, and I'm probably better at this than other things, is how you make your way to the solution. And so, like for example, for me, for example, this is probably the fourth programming language that I've had to learn really well, and I'm not really there yet with C#. So the way I get stuff done is I rely on sources, on references, and so part of what I do up here is to show you that. And because if you're programming in 10 years, you're going to be doing the same thing, because you're probably not going to be programming in this language. You'll be programming in some new language, and you know, you will, by then you may have 3 programming languages that you know really well in your head, and you know, you're going to make little mistakes now and then. Fortunately, our integrated development environments are so good that, you know, they put squiggly lines and so on and make suggestions, and that helps you, you know, get your stuff done. So what I'm going to do is I'm not going to change anything. I'm just going to add the two-dimensional array. So I'm going to start by So I'm going to start by going in here and declaring, where do I declare my old array? Okay, I'm going to declare a two-dimensional array right here, private string, and I'm going to do square, comma, n square, array friends, 2D, equals new string size, same size, but it's going to be a 2, and there can be there's 2 columns. Okay, so now I've declared my two-dimensional array with 2 columns, and I also want to keep track of this free friend index. This points to the first free index in the array. I want to keep track of that separately too, just because I don't want to. They should be the same all the time, but so I'm going to declare private int. I'm going to call it FFI2D equals 0. First free index 2D. That might be too confusing. First free index 2D. Okay. So where do we load up the array? Where do we load the array? Well, we add a name here, but where do we really load it up? It turns out, I was going over this code this morning. Oops. And this is not used anymore because but we may use it again, so I'm just going to leave it. Button load file, click, oh, here it is. Here's where we load the array, all right? So here we load up this array. So, let's see. Should I use the same loop? What the heck? I'm gonna use the same loop. All right. So this. All right. I at least have to do this. I'm gonna take this out of here and put new name, and I'm gonna put. String new name equals that. And this is, I really do want this to be new name. Okay, so I've separated that out, and this dumps it into here, but now I need to dump it into my other array. So let's see. First, I'm going to split new name into first name, last name. Yeah, first split it into first name, last name. String, it's a string array, names equals new name dot split. Okay, that does it. And then I'm gonna see. I actually have some notes here. Instead of doing this from memory, I'm gonna separate them out. String first name equals names. This helps you to see what's going on. And the last name equals names 1. Oops, names 1. Okay. All right. Now, when I add, all right, the old way, I just added it to the end of the list, right? I just added it to the end. But this new way, I need to store the names store the names in alphabetical order. So I'm going to use this insertion sort method, and if I had time, I should use. There's some nice animated graphics on how insertion sort works, but I'll try to explain it as I go along here. So I've got first name and last name, and what I'm going to do is I'm going to loop through the array, the names array. It's actually empty to start with, but as we add names, once we add names, once we're done adding the name, the array will always be in alphabetical order. So once we add one name, of course, it's in alphabetical order. When we add the second name, it's going to either add it as the last one or the first one, depending on which order it should be in, and so on. So the way I do that is I'm going to start at the top, at the very end of the array, and I'm going to shift names down to make an open spot above the name if the new name should go before the name I'm looking at in the array. So let me start by declaring an integer loop variable called, I'm going to call it the index, and that's going to equal to the first free index 2D, because we're working with the 2D array right now. And then I'm going to do a while index is greater than 0 and string compare while the array friends 2D index -1, the one right before it, comma 1, because we're talking about the last name. While the last name in the array that we're looking at is bigger than the last name, case insensitive. If that is greater than 0, then it's bigger. That means the one we're looking at in the array is bigger than the last name here. If that's true, then we want to shift it down. And the way we shift it down is we say array friends 2D index comma 0 equals array friends 2D index -1 comma 1 comma 0. That shifts the last name down. I got to shift the first name down. One. I'm sorry, that shifted the first name down. This shifts the last name down. And we decrement index by 1. And so this thing is going to loop, shifting names down until it either reaches the top or it encounters a name that should come before this name alphabetically. And so right now, index is going to be pointed to the first free spot. So index is going to be pointing to the spot where we can insert the name. Now, I want to change it so it's, while I'm here, this class goes till noon, right? While I'm here, I want to do this part here. This, why isn't this working? Well, sometimes this works and sometimes it doesn't. So anyway, forget it. So here's how I do that. Well, here's how I figured out how to do it. Let me close this. I said C#, first letter uppercase. And you end up with something that looks like Stack Overflow is pretty good. Let's see what Stack Overflow says. No, this is not anything like I was looking for. I don't want it to be that complicated. I'll just tell you what I did. I do first name equals a character method to upper of first name bracket 0, because I can take a string and treat it like a character array, and that's what I'm doing. I'm taking the first letter of the first name, so that's the first letter of the first name, the first character of the first name, and I'm making it uppercase, and then I'm concatenating that with first name dot just the substring starting with the first character, not the 0th character, but the first character, starting with character number 1, not character number 0. And the way you do that is there's this function, this method called substring parentheses, and then you say what the first starting index is, and so it's going to be index number 1. Okay, so wait a second, I want to make this lowercase. Wait, this makes the first letter uppercase, but it doesn't make the remaining letters lowercase, does it? I better do this first. First name equals first name to lower. There. Now that makes all of the first name lowercase, and then this takes the first character and makes it uppercase, and then it just appends the remaining characters on to that. So that'll make the first name uppercase, or where the first letter is capital, and this is the last name. Dun, dun, dun. All right, so that takes care of that, and now I want to add it into my array. So ARR friends 2D index comma 0 equals first name, and ARR friends 2D index comma 1 equals last name. And then we have to, just as we did here we incremented first free index by 1. You know, we could do it that way. We need to increment this by 1 also. So I'm just going to put this down here, this plus 1. All right, so this will add the the new name into the array in its proper order. And it's all inside this. So this while loop reads the names in one at a time, and then this inner while loop inserts them into the proper place. So the absolute worst case is if we read in names and they're in reverse alphabetical order. Because if they're in reverse alphabetical order, we read in all the names, and so that's like if there's 100 names, that's 100 times we read it in. And then in here, this is going to have to shift every name down as many times as the first name that it puts in there. It's going to have to shift that down as many times as there are names, because it's starting at the top, and each time it's being shifted down one. So this algorithm could potentially take a long time if we've got lots and lots of names, and the file we're reading in is in reverse alphabetical order. Although presumably, when once we read in the file, once it becomes alphabetized and we write it back out again, we're going to write it back out in alphabetical order, because it's being stored in the array in alphabetical order. Then that amount of time to do the original sorting will only happen once. All right, so all right, this is going to make sure the array is sorted. And let's find where we populate the array, or let's find where we populate the list box and populate our second array. Remember, we've got or the second list box. And where is that now? List box. Load array, populate. Oh, here, populate list friends. Okay, this loops and populates the first list box. I'm just going to put the second one here. LST friends. Didn't I name it something? LST. I didn't name it. Oh, I didn't add it yet. I'm getting ahead of myself. I'm going to put a second. I did that. I'm going to put a second list box here. List box. And this is going to hold the list box that matches the two-dimensional array. So I'm going to name this list box LST friends 2D. That's all. All right, let's go back here again. LST friends 2D dot items clear. That clears it out. For int index equals 0, index is less than first free index 2D, index plus plus, parentheses, string name equals array friends index, array friends 2D index comma 0, that's the first name. Put a space in between the two names. And then the last name is ARR friends. There should be an S here. Friends 2D index comma 1, which is the last name. So that creates this string, this name, and then we say LST friends 2D equals items, do dot items dot add name, same. Okay. All right. So whenever the first list box gets populated, the second one does also. Okay. Now we can take a look and see if this works. Okay, here we go. Let's load a file with something. Let's load this one. And oh, look, it's there. And we see that this one, the second one is in alphabetical order. Charlie Brown is first, Fred Johnson is second, Joe Schmo is third, and Mary Smith is fourth. That's alphabetical order. All right. But when we add something, we don't have it yet. Aiden Akamini. It only adds it here, doesn't add it here. I'm going to save that. And let me, so I need to, okay. So I also need to, insert, here's where I insert it into I insert the name into the array, the first array. I got to insert the name into the second array too. I'm going to, where do I load up the second array? Here is where I load. Here's where I load the second array. I'm going to make this a method. I'm going to grab this here. I'm going to X, and I'm going to say, I'm going to name my method insert new name. And I'm going to take as a parameter new name. Okay, so I'm going to make my insert new name method actually do the splitting. I'm getting a red squiggly because it's not defined. I will define it right down here. Private void. It's not going to return anything. Insert new name, and it's going to take in a string new name. Okay, so I'm going to call it the same thing inside. And then let me paste this. And all right, it might just work. Okay, so takes in new name, splits it, first name, last name, inserts it into the first free index, increments the first free index, and that's the end of that. So here's insert new name. So now I can use this one up here. Except for I still got to do that duplicate thing, don't I? Well, what the heck? I'm gonna do the duplicate thing. Let me just copy all this code here. This code, copy. Right here. Oh, I'm gonna put insert into two-dimensional array. I'm gonna do that right here, and I just pasted that in there. And so let's see, duplicate. I've already declared duplicate up here. I can just take this off, and I can reuse that variable. I can reuse this variable. And this is first free index 2D. Duplicate is false. Oh, this is getting a little more complicated here. I'm not going to insert that yet. I'm going to do it better. I'll just keep doing it this way. 2D, index, comma 0, lower is equal to new name, lower. If that's true, and I'm going to go down here, and this is true also. Gotta split it up, I guess. Shoot, string names. I'll just use the same. Equals new name split. And this has got to be names. Names to lower. This is names 1 to lower. Okay, so what this does is this looks and sees, okay, so what this loop is doing is it's seeing if the name is already in there. So, but it's got to do first name, last name separately, because that's how they're stored. So this takes the new name, splits it up into first name, last name. Names 0 is the first name, names 1 is the last name. And so it compares the first name together. And so if that's equal, ignoring case, and the last names is equal, then we have a duplicate. So it does the same thing there. And then right here, instead of doing this, we could just do insert new name, new name. And so, and I went ahead and left this there. Why? Because it's redundant, but really what you're going to be doing is you're going to be taking out the old one, okay? So I'm just sort of showing you a way that I would develop the assignment 11 from assignment 10. And the way I do it is I have both there for a while. You know, I have the second one, and once this second one's all hooked up, and I'm saving the file, I'm unfriending, I'm doing all that, then I can get rid of the first one, and I can get rid of the remnants of the first array. But let me test this. So now we've got these names in there, and I see Aiden is in there, and let me try to add another name. Alan Zanzibar. Zanzibar. Oh, it should add them both to the end. Oh, what happened? Why did add friend? Oh, something's not working, is it? Let's see. I'm in a tight loop somewhere. There's a while loop that's going on that's not letting me. Oh, what do I do? It's not closing the window. All right. Let's see where the loop was. There's this loop. Oh, I know what the loop was. Right here. I never increment index, do I? I never. Index plus equals 1. Or index plus plus, however you want to write it. I didn't do index plus plus or index. Okay, so it kept on. It kept on loading up the array. No, it wouldn't have done that. It would just. It just stays in a forever loop, I guess. All right, let's try it now. Load file. Oh, wait a minute. Let me. There we go. Load file. This one again. So there they all are. And so let me add in Charlie Mayweather. And gets added on the end here, but it gets added right in the middle here. Joe Zanzibar. The end of both. Allison Adams. All right, so let's try this. AIDAN Akamine. This is the first one, and this is the second one. Okay, so they're both checking. All right, let's see. So I think we've done that. We've done the split. We've stored the display names in alphabetical order, inserting the names at the bottom. Okay, so I guess all that's left to do is to hook up all the rest of the buttons so it works with the two-dimensional array rather than just the single-dimension array. And so let's just review. It's towards the end of the class, but let's just review where that would be. Save file is we use this write array function, and this write array function just uses the first friends, the one-dimensional array, and we can just change this to do the two-dimensional array. We can do something like string new name. Well, right. We can just do something like this, in fact. 2D, comma 1, comma 0, plus space, plus array friends 2D index, comma 1. And that appends the two, that appends the first name followed by space followed by a last name, and it would write that instead. So in other words, we could use this instead. That's for the write, and then for the unfriend, we are looping until we find the friend, right? Yes. I think what we loop until we find the friend. Oh no, we've selected the index. Dumb. Yeah, so we need to just do the selected item, the selected index for the second one. We don't name to delete. We can sort of put that together after we pull out the name. Oh, I guess we have to actually split it because we have to compare with the first and last name from the. So we have to pull it out of the list box and split it into first and last name, and then when we do this, the no, it should be the same. The index will be the same as in the array because the array represents the list box exactly. So you can just delete that location in the array. Anyway, so that should take you to the end, and then you would pop this out. So I'm gonna close up now. Are there any? How do I? Am I still sharing? No, I'm not. Are there any questions? All right. So I'll put this up, and thanks for watching.